Hey everybody, we're back to doing some trigonometry. Today we're going to cover graphing tangent and cotangent graphs. Again, this is Math 154 at College of the Sequoias. It may be a different number for you guys. This is section 6.5 in our book. It's probably in chapter 2 or 3 for yours, depending on how your book is if you're at a different school. But for us, 6.5, graphing tangent and cotangent. Wow, camera wants to shift around. Wiggle, 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 yeah. There we go. Graphing tangent and cotangent. And I want you to recall, it's a little bit different. We have tangent. Recall that tangent of pi over 2 is sine of pi over 2 over cosine pi over 2. Which is 1 over 0 and is undefined. The same is true for tangent of negative pi over 2. Slightly different. It's negative 1 over 0, but still undefined. In fact, for n pi over 2, tangent of n pi over 2 equals undefined if n is odd, and it equals 0 if n is even. And that includes 0. And obviously here n is an integer. So our period, the period for tangent and cotangent, the same holds true for cotangent, but it's got different zeros and undefined. The period for tangent and cotangent is not 2 pi. In fact, if we do pi over 2 and we subtract negative pi over 2, the previous undefined, we get pi over 2 plus pi over 2, which is pi. The period is pi. Okay. And we can look at some, let's just make a quick chart of tangent and cotangent for some different values. Let's look at the values between negative pi over 2 and pi over 2. And let's look at the ones that are on the unit circle, the ones that we have memorized. Okay. So we'll do, that is tan x, this will be tangent x, and this will be cotangent x, okay? We already said these are undefined. And this one's 0. And I'm gonna make a quick note that this is negative 1 over 0, and this is 1 over 0. Because cotangent, we flip over tangent, that makes these 0. And this was 0 over 1. When we flip that over, cotangent is undefined as 0. What about the other ones? Well, the diagonals were easy. Pi over 4 and negative pi over 4, those were just 1 or negative 1. In quadrant 1, it's positive. In quadrant 4, it's negative. Pi over 6, the 30-degree mark, we had root 3 over 3. And pi over 3 was, let me do it in, I want to change the color a little bit. Root 3 over 3, and this one's root 3. And so this one over here is negative root 3 over 3. And this one's negative root 3. And to graph these, this is about negative 1.7. This is approximately negative 0.6. So when we flip these over, well, cotangent doesn't change for the diagonals, the multiples of pi over 4. We flip this one over, it just changes. We've got 1 over root 3. This becomes the root 3 over 3, and it's 0.6. This one becomes the root 3, which is 1.7. And so same thing over here. We've got the negative root 3 and the negative, ooh, I wanted blue on these. Negative root 3 over 3, which is negative 1.7, and we got negative root 3 over 3, and this is negative 0.6. So let's take a look at graphing those. I'll pause and let you write that stuff down. Okay. Let's take a look at tangent first. I'm going to leave this sitting up there where we can see it, because that way we're not having to flip back the previous page if you got it that way. So let's do y equals tangent x. Okay. We just got done saying that negative pi over 2 and pi over 2 are asymptotes, or are undefined. When it's undefined, it's an asymptote. That's y, this is x. So we've got magical barriers right there that we cannot cross. And we go another multiple, and we have 3 pi over 2. We'll have another asymptote. And for a quick recall as graphs approach asymptotes, they get really close to it but never cross. I like to refer this as, if you've seen the movie Tron, these are like Tron cycle walls. In Tron, they're on motorcycles that leave behind trails of light, and the object is to make someone else on a motorcycle crash into your trail of light, and it kills them. So they ride close to the wall, but don't cross it. All right, so what do we have in between? We've got pi over 6, pi over 4 is in the middle. Pi over 6, pi over 3. Pi over 4 is in the middle. Pi over 3, or negative 1, negative 1, negative 2, 2. Okay, so what do we have for tangent? The origin is a point on the graph. And at both pi over 4s, we're at an increment of 1 and negative 1. Now we can tell if it's going up this way, it must be going towards the asymptote upwards on the right. And if it's going downward on the left, it must be going towards it on the left that way. We can put in the other points just to illustrate it. 0.6 is about there. 1.7 is up higher. And the graph does something like this. In fact, when we get over here, we have something similar. So y equals tangent x looks a lot like y equals x cubed, but it keeps repeating because it's periodic. Okay. And it's worth noting the asymptotes let's try this again. Asymptotes are at n pi over 2, where n is odd. Okay. Pause right there. Get your stuff together. Okay. So up above, I did cotangent between negative pi over 2 and pi over 2. But those aren't the asymptotes. Undefined is at the 0. And it's actually at even multiples. Everywhere tangent equals 0, at n equals even, which means cotangent of n pi x is undefined there. So maybe let's do our chart from 0 to pi. What do we got first? We got pi over 6, we've got pi over 4, pi over 3, pi over 2, 2 pi over 3, that's the next one. 3 pi over 4, 5 pi over 6, and then pi. Cotangent of x. These are our undefineds. And this one's 0. These ones are 1 and negative 1. The pi over 4 ones, all for tangent, cotangent, have 1 or negative 1. And then we showed what this was up here. We can just pull it down real quick. This was root 3. This was root 3 over 3. And when we get around to the left side, now cosine is negative, sine is positive. It's the negative version, and it mirrors the left side, so negative root 3. And this was 1.7, 0.6, negative 0.6, 1.7. So let's take a look at graphing cotangent. Y equals cotangent x. Actually, we know that's an asymptote, so maybe I'll just make it dotted now. Ooh, my black pen's dying. Time for a new one. So this is the y-axis. This is our x-axis. This will be pi. This will be 2 pi because it's odd multiple or even multiples of pi. In between them, we've got pi over 2, 3 pi over 2. Let's make that 1 and -1, -2 and +2. And we start plotting them. What do we got? The pi over 2s are our zeros, the odd ones. For cut those in quarters. And then I'll put in the 30-degree marks. That's pi over 4, 3 pi over 4. So to the left of the 0, these values, they're positive. So that's a positive 1 there. That's a -1 there. And we got 1.7, 0.6, -0.6, -1.7. So it's kind of like tangent. This repeats. Here, the vertical asymptotes are at x equals n pi, where n is an integer. All the multiples of pi. Okay. So kind of like tangent, it's flipped and it's shifted, but it's similar to that. Let you finish writing that down. Then we'll start looking at shrinking and stretching and stuff like that. Okay, so let's talk about the 5 points I worry about when I'm graphing tangent and cotangent. We had 5 marks for sine and cosine, the endpoints, the midpoint, and the 2 quarter points. Here, I focus on the endpoints being our asymptotes. The midpoint is 0, and the quarter points are 1 or -1. I don't worry about the pi over 3 or pi over 6 marks. And the reason why is once I know which side, whether it's +1 or -1, the quarter points tell me which way we're going to start doing our Tron cycle. The quarter points tell me if I'm approaching the asymptote on the positive side of y or negative. Positive or negative side for y. All right. Now, if I really needed something official, like fine detail, I obviously wouldn't do it by hand. I'd do this in a computer program. So let's take a look at what happens when we do tangent. Let's do y equals a tangent bx. So first off, the a, it changes the quarter points to a and negative a. That's all it does. Now what's the b do? Recall the period for tangent is pi. And we initially had negative pi over 2 is less than or equal to x, not less than or equal to, less than. We can't have the equal portion because it's an asymptote. And now we're going to replace x with bx. So I got negative pi over 2 is less than bx, which is less than pi over 2. We divide by b. And we get negative pi over 2b is less than or equal to x, which is less than or equal to pi over 2b. Now, I want to be able to break this up into 4 points. I want my quarter points. So I'm going to multiply this by 2 over 2. And I'm going to get this. Negative 2 pi over 4b is less than x, which is less than 2 pi over 4b. And that gives me points at negative 2 pi over 4b, negative pi over 4b, 0, pi over 4b, and 2 pi over 4b. Now, as long as you can get to here, and if you're okay breaking down and finding the quarter points, please do it that way. I think it's easier having these when we get to the shifts, the translations. So both methods work. Let's take a look at what's going on with cotangent. Pause and let you finish writing that. All right. So we've got y equals a cotangent of x, or a cotangent of bx. Again, a changes the quarter points. To a and negative a. Here we were going from 0 less than x less than pi. Now we'll make that 0 is less than bx less than pi. And we divide by b, we get 0 is less than x less than pi over b. And I want to be able to break this up into 4 pieces. If I get this to have 4 pi, I can go 0 pi over b. This is the goal, having 2 pi, 3 pi, 4 pi on top. What do I got to do to get there? I got to multiply that by 4 over 4. So I'll have 4b on bottom, just like on tangent. Okay. So for cotangent, we've got 0 is less than or equal to x, which is less than or equal to 4 pi over 4b, or that one, whichever one you like. So when we graph them, again, what's step 1? Find your 5 marks. Sketch asymptotes at the endpoints. And 0 at the midpoint. For tangent, the first quarter point is -a. The second quarter point, I guess really the midpoint's the second quarter point, but you know what I mean. There's 2 points that are in the quarter areas. This is +a, and this flips for cotangent. First quarter point is -a. Second quarter point is +a. And finally, sketch the graph by Tron cycling towards the asymptotes. Simple as that. So let's take a look at doing some. Pause that if you need it up longer. So let's take a look at y equals 2 tangent of 3x. First, we need to identify a and b. A here is +2, b is 3. Tangent goes from -π/2 to π/2. So -π/2 is less than 3x is less than π/2. We divide by 3, I get -π/6 is less than x is less than π/6. And I multiply these by 2/2 so that I can do my quarter points. Those are these show my asymptotes. The asymptotes are easiest to see there. So every π/6, I have an asymptote. Put my quarter points in. So each mark is π/12. All right. Tangent is at -a, so a is 2. Let's put that in. 2, 1, 2. Tangent is -a on the left quarter point, +a on the right quarter point, 0 in the middle, and we Tron cycle or approach and never cross the asymptotes. And this is repetitive. Simple as that. And recall, when we're only doing the quarter points, not the π/3 and π/6, they look like they're on a straight line. Midpoint and quarter points look like a straight line, or quarter points look like they could be on the straight line. So don't forget the curving or twisting effect. Or turning, like x cubed. Okay? Ready for more? Let's take a look at one for cotangent. Let's do, we had A and B being greater than 1 there. Why don't we do less than 1? Let's make this y equals 1/3 let's make it 1/2. 1/2 cotangent of 1/3 x. Let's do that. We had 2 tangent 3x. Let's do 1/2 cotangent 1/3 x. So A is 1/2, B is 1/3. I had 0 was less than x, which is less than pi. I'll put my 1/3 in. That's the one of the domains, one set of the domains, one period. We multiply by 3 and we get 0 is less than 3x is less than, 0 is less than x is less than 3 pi. Now, if I wanted to, I could make this 12 pi over 4. 12 pi over 4. Midpoint is 6 pi over 4. Half of that is 3 pi over 4 and 9 pi over 4. I think getting like the halfway mark would be 3/2 pi. The midpoint there is pretty easy. Without using the 4, just doing the midpoint there is pretty easy, 3/2 pi. And even doing the first quarter point is pretty easy, 3/4 pi. This one, not so simple. Okay, so that's why I like getting a different base. So it makes it so I have sketching easier. So I have an asymptote at 0. So that's my y-axis. And I have asymptotes at every at 3 pi. That is, I'll put my 6 pi over 4 there. This one's going to be 18 pi over 4. $12 pi over 4. That'll make this one 24 pi over 4. And we've got 0 in the middle. And here, the first quarter point is at A. So if that's 1 and that's -1, we're actually only going up halfway. So it's a little bit flatter. It has to get towards the asymptotes a little bit quicker as it goes up. All right. All right. The big kit and caboodle with our translations in there. Here, I would, when you have a shift, translations, especially a horizontal translation, D affects the location of your asymptotes. So don't sketch them right away. Okay. So 2. Find the 5 marks of tangent BX or cotangent BX. Shift the endpoints right if it's x minus d, or d is greater than 0, basically, and shift it left if it's x plus d on the inside. So d is less than 0. Okay? So sketch your asymptotes there. What it happens to end up being, tangent, their asymptotes are at negative pi over 2 plus or minus d, whichever one it is, and pi over 2 plus or minus d. And then we have cotangent, is 0 plus or minus d, and pi plus or minus d. Those are our asymptotes. In fact, when you shift the endpoints, shift all 5 points. Mark your midpoint at 0. And quarter points at A and negative A. Then shift up by C. If C is negative, you obviously shift down. So you'll really be at A plus C and A negative A plus C. And then draw your graph. So let's take a look at a couple. Well, they're actually all kind of the same. Doing one is sufficient. Then we're going to look at finding the equation from a graph. So let's take a look at, when you're ready, tell me are you ready? All right. So let's do y equals -1 minus 3 tangent of 2 times x minus pi over 2. Recall, we need to write it in the right form. B has to be factored out. I pull out the 2, and I've got x minus pi over 4. So my A is -3, B equals 2. C is -1, so we're going to move it down. And D is the opposite sign of this. D equals +4. We're going to go right. Okay. Where are our points? We have -pi over 2. is less than 2x is less than pi over 2. It says negative pi over 4 is less than x is less than pi over 4. And if I double it, negative 2 pi over 8, 2 pi over 8. I get 0 in the middle, and this allows me to do a negative pi in over the 8 and a 0 and a pi over 8 there. Okay? I will show you another way of doing that after we do this graph. You might like it differently. Some people do. So what do we got here? What's our shift of D going to be? It's going to shift it by 2 pi over 8 if I get a common denominator. So, wait, I want a little bit more room. Here's my x-axis. I don't know where my asymptotes are going to be, so I'm just going to mark 0. Negative 2 pi over 8. 2 pi over 8. 4 pi over 8. 6 pi over 8. 8 pi over 8. All right, so I'm at, these are my marks here, 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 and here. They get shifted. My marks are now from 0, they go right 2 pi over 8. So we're going to go from 0 to 4 pi over 8. Those are going to be my asymptotes. So I'll have asymptotes at 0 and 4 pi over 8, which we know is pi over 2. Which means this one here, obviously, is 8 pi over 8 is pi. All right. We've got a equals negative 3, so I at least need 3 hash marks here. 1, 2, 3. 1, 2, 3. And the negative 1 tells me I'm going to go down another one, so negative 4. So my midpoint's normally at 0. It goes down by 1 because of C. My first quarter point for tangent is negative A. A is negative 3, so it's going to be positive 3. And I'm going to lower it down to 2. That's a 2 right there. And the second quarter point, or the fourth mark, is positive A. Positive A here is negative 3. And we're going to drop it down to negative 4. And we'll do our asymptote cycles there. Okay. Here's another thing you can do to do those, find those marks. This is an alternate choice. Some people like it, some people don't. I tend to like to graph or put where the base graph is and shift it. If I do that for sine, cosine, tangent, and all of them, it's the same pattern. I only have to memorize one thing for each thing, or one thing for all of them. Do the base and shift. Do the base and shift. I'm going to put up that same thing, and we're only going to look at what we had. We had, without A and C, we had tangent of 2x minus pi over 2. And we showed that ended up giving us 0 to pi over 2 were our asymptotes. We saw that on our graph. Let's do this another way. We've got 0 is less than, or I'm sorry, Negative pi over 2 is less than or equal to x is less than pi over 2. We're going to sub that in. And solve for x. We add pi over 2 to both sides, or all three sides. We have 0 is less than or equal to 2x is less than or equal to pi. Divide by 2 everywhere, and you get 0 is less than x is less than pi over 2. Same asymptotes. At this point, you can still multiply. I want 4 points. This is only going to give me, I want 5 points. I need to break this up into this range up into quarters. So I'm going to multiply this one by 4 over 4 and this one by 4 over 4. The reason why I did it here is I want to make it clear it's you do it on the same side, each side. Even though this is 0, if it's not 0, you still need to do it. So I've got 0 is less than or equal to x is less than or equal to 4 pi over 8. And now you can see that we got 0, pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. This is an alternate way of taking care of the horizontal shift or horizontal translation. And it works on the sine cosine as well. So I'll give you an alternate way of doing it. Some people don't like that whole algorithm of what I was doing before, shifting the graph. I think it's the easiest way to do it. This is a little bit more clear of why the asymptotes are there. We're changing the argument, but the period is still the same. So we put our period endpoints in, we put the argument of the trigonometric function in, solve for x, and that'll give us where the ends of the period are. All right. Let's determine an equation from a graph. Let's give it a try. So let me graph it. This is pi over 2, pi over 4, negative pi over 4, negative pi over 2. So that's our graph. So what does this look like? This, well, the first choice, obviously, it looks like tangent. It's got the same asymptotes as tangent, so b equals 1. And our quarter points are at 6 and negative 6, so a equals either positive or negative 6. This is upside down, though. Tangent goes up on the right. So this would give us a equals negative 6, y equals negative 6 tangent x. Your other option Cotangent is 0 less than x less than pi. So this could be cotangent shifted left by pi over 2. Right? Or right by pi over 2, because it repeats. If we do it this way, now the graph is not upside down. So A is going to be 6, positive 6. And a shift left means we have an x plus d. So we could do, this could be y equals 6 cotangent of x plus pi over 2. And conveniently enough, if we shifted it the other way, it could also be 6 cotangent of x minus pi over 2. That would just be the next asymptote over here. Okay? And why does that work like that? Just a quick reminder. Remember our cofunction identities? We had cotangent of A equal tangent of pi over 2 minus A. And this is the same thing as negative tangent of A minus pi over 2. Because the graph just flips over. Same thing here, I could do tangent A. This is cotangent of pi over 2 minus A. These are our identities. And the reason why this happens over here, if you look at the graph of tangent and cotangent, both tangent and cotangent are odd functions. And recall an odd function, f of negative x equals negative f of x. So I could say this is tangent of negative a minus pi over 2. That's the same thing as tangent of pi over 2 minus a. But then using the odd function property, I can pull the negative sign out and have a minus pi over 2. And that's why that works. Well, that'll get you graphing cotangent and tangent. 6.6 will be on secant and cosecant. And those are really, really easy. We're going to graph sine and cosine first, and because remember, secant and cosecant are the reciprocals of sine and cosine. So we'll graph sine and cosine, and we'll just flip everything. We'll see how it works. We'll do that shortly. Peace. Have a good day.